to our advisor, Professor Jemmer A. Alimbon, to our panel experts, Professor Karin Crislin A. Vitor and Professor Lovely May R. Prieto, to our subject teacher in Research 1, Professor Mark John Angelo H. Pakal, greetings and good day. We are the group Z3137, and this is our outline proposal of our thesis study entitled Assessment of Freshwater Fishes in Maduao River, Maco, Davao de Oro. This presentation focuses on the introductory part, which will be shared by yours truly, and the methodology by my co-researcher, Ms. Alonzo. According to me et al. 2016, fish diversity is an essential indicator of the health of river ecosystems. Various biotic and abiotic processes influence fish species distribution, presence, and absence. As per Arthington et al. 2016, there are approximately 13,000 freshwater species found in rivers, lakes, and wetlands. In the Philippines, as per data on the fish-based database, there are 226 freshwater fish species found. That is 1.74% of the totality. Now, if we will look at the Earth's water distribution, 97% of it are ocean bodies, while the remaining 3% is fresh water. However, fish inhabiting freshwater ecosystems is still bountiful even with its little portion of the water's distribution. Thus, as stated by Wang et al. 2018, this data simply shows that fish is the most abundant vertebrate group globally, inhabiting ecosystems with diverse ecological types found in different countries, regions, and environments. However, Tassima and Muhammad 2016 asserts that freshwater biodiversity has declined more rapidly over the last 30 years. Currently, species extinction has been identified to be 1,000 times faster than those registered in the fossil record, according to DeVos et al. 2015. Our wetlands are disappearing 3 times faster than forests, as per Gardner and Finlayson 2018. And according to World Wildlife Fund 2020, freshwater vertebrates decrease faster than their terrestrial or oceanic relatives. Globally, in China, the rivers and streams have undergone noticeable changes affecting fish diversity. In Jiangxi, the Ganjiang River, which we can find in the figure, their species richness and diversity indices were found to be both low, along with the analysis of abundance that suggested moderate disturbance. A similar study by Su et al. 2021 was also conducted in Balay River in Borneo and deduced that anthropogenic activities in the basin had altered environmental variables, thus disrupting the fish assemblages. Kang et al. 2009 also evaluates the overall risk of the upper Mekong, the Langkang River, and discovered that water pollution and hydrological volatility are the most enormous threat in the basin. Lastly, in Weihe River Basin in northwest China, Cheng et al. 2019 found out that the ichthyofauna composition varies notably between rivers, and this variation was greatly influenced by habitat conditions, environmental factors, and human impact. In the Philippines, diverse ichthyofauna studies were documented. A study on fish species composition, diversity, and distribution were conducted and documented by these several researchers. We have here the legends and their corresponding location in the Philippine map that is indicated in the figure. We have Corpus et al. 2016 in Lake Taal River System, Batangas, Codal et al. 2019 in Mount Timulan Protected Landscape, Zamboanga del Sur, Paler et al. 2011 in the watersheds of Mount Makiling Forest Reserve, Laguna, Paler et al. 2013 in Tayabas River, Quezon, and a study by Riquiron and De Mayo 2015 in the Iligan River, Iligan City. Species richness, abundance, and physicochemical properties was also evaluated by Uhaw et al. 2021 in Ihawan Spring Community Watershed, Tandag, Surigao del Sur, Kimpang et al. 2020 in Matingao and Marbel River that flows around the parameters of Mount Apo Natural Park. Land-weight relationship of freshwater fishes was also being studied by Dinusta et al. 2020 in Tigum River, Iloilo, and Escote and Humawan 2017 in Santa Ana Dam, Nabunturan, Compostela Valley. Locally, particularly in Davao region, though assessment of freshwater ichthyofaunal diversity was conducted in few areas such as Dumagook and Maog rivers, by Kimpang et al. 2015, Kimpang et al. 2016, Dapar et al. 2021, and Banahaw River, also conducted by Dapar et al. 2021 in Mount Hamigitan Range Wildlife Sanctuary in Davao Oriental. Such data and other river systems within the region remain scarce. To help address this deficiency, the researchers seek to assess the freshwater fishes in Maduao River, Maco, Davao de Oro. Specifically, it aims to classify the fish up to the species level and to determine the species diversity, richness, dominance, and relative abundance. The outcome of this study will give benefit to the various stakeholders. We have the Department of Environment and Natural Resources Biodiversity Management Bureau, the local officials and barangay officials of Municipality of Maco, particularly in Barangay Concepcion, and lastly to the future researchers. This study specifically aims to assess the biodiversity of freshwater fishes in Maduao River, Maco, Davao de Oro. Specifically, it aims to classify the fish up to the species level, to determine the relative abundance of identified species, and to determine the species diversity, richness, and dominance in the study area. For the methodology part, we have here my co-researcher, Ms. Chandishin P. Alonzo.
In this slide and the following, I will present the methodology of this study. The field work will be conducted at Maduao River, located at Maduao Concepcion, Maco, Davao de Oro. The site consists of sand and gravel within its riverbed and has a slow velocity in its water flow. It has waterfalls upstream and a primary and secondary forest. Vegetation such as coconut, banana, and bamboo are present midstream. Downstream consists of homes such as residential areas, a primary school, and a chapel. The river is located 4.4 kilometers away from the barangay's provincial road. All necessary approval and permits will be sought before the conduct of the study. First, we will obtain an approval letter from the Dean of College. Once approved, prior clearances from the indigenous cultural communities and concerned local government unit will be sought. Also, consent from private landowners will also be secured if there is any. Lastly, acquisition of gratuitous permit from the Department of Environment, Natural Resources, Biodiversity Management, Bureau 11 will also be acquired for capturing wildlife species from their natural habitat. 3 sections of the river, upstream, midstream, and downstream, will be used in this study. The S1, S2, and S3 represents the upstream, midstream, and downstream. The station 1 will be the upstream, station 2 is the midstream, and the station 3 is the downstream of the river. Each sampling station will be measured 100 meters stream reach by the use of a measuring tape. Measuring will start from the upstream, which is the upper part of the river. The same procedure will be established in the midstream and downstream as an indicator to the individual stations. Each sampling station will be sampled at daytime, lasting for 1.5 hours for 7 days within a month. Fish specimens will be obtained using fishing methods and gears such as seine net, fish trap, hand net, and backpack electrofishing. The seine net, measuring 1.2 by 1.2 millimeter mesh, will be placed in a selected area of the riverbed facing the opposite direction of the water flow. The net will be embedded in the river for 1.5 hours along with the fish trap that will be placed to another area of the river. While waiting for the seine net and fish trap to capture fishes, backpack electrofishing will be used in other areas within the station with 10 volts, enough to stun the fish. The hand net will be used to catch the fishes that are stunned by the backpack electrofishes. Upon capture, all fishes will be identified on site, will be placed in a bucket for documentation, and some unidentified will be preserved for further identification. All debris and organism will be handpicked from the net, and any non-fish species caught, such as macroinvertebrates, amphibians, and eels, will immediately return from or to the river. Fish species will be identified by examining its morphometric and physical characteristics such as their standard length, its color, number of fins, presence of barbels, shape of the head and tail, body, and its mouth structure. Fish species identification will also be done using field guides and other relevant materials and databases, such as the Raffles Bulletin of Zoology by Cotelat 2013, rainbots fishes of the Cambodian Mekong, and published articles that reported freshwater fishes in the Philippines will also be used, such as et al. 2021 and the Pars et al. 2021 study. Verification of the species initially identified will be done with fish base or by experts if necessary. The data will be analyzed using the following indices, such as the Margalef index, which calculate the species richness, the relative abundance, the Shannon-Wiener diversity index that will be used to characterize fish species diversity, and Simpson's index that will specify species dominance. The collected data will be analyzed using paleontological statistic software package or PASS software by Hammer et al. 2001. And this is our references and the last slide of our presentation. That could be all, and thank you.